Okay, so today we are going to solve the inequalities. So these are, we have three absolute value inequalities and one regular inequality. And we're going to solve for them. So let's start with number one. The absolute value of x minus 14 is less than or equal to 20. So this is an absolute value. I'm not going to go over absolute value too much today, but absolute value is basically just kind of like a measure of distance. It always has to be positive. So keeping that in mind, in order to solve this, we write a negative 20. We use the same symbol right here to write next to the negative 20, less than or equal to. And then we get rid of the absolute value and we write x minus 14, again, less than or equal to 20. And now we can solve by leaving x by itself. The way we do that is we add 14 to each side. So because the 14 needs to cancel out, so that's why we add 14. Oops, 14. This obviously cancels out. This is going to equal to positive 34. This is going to equal to negative 6, I believe. Negative 6. So negative 6, and the x is by itself. We bring down the symbols. So negative 6 is less than or equal to x, and x is less than or equal to 34. So this is indicating that x is between these two values. But since we have this inequality with the equal sign at the bottom, this indicates a bracket, which also, when you draw the graph, it also indicates a closed circle. Why? Because it's indicating that the endpoint is included in the inequality. So we write this as bracket negative 6 and then 34 bracket. So this is indicating that x is greater than or equal to negative 6, but 34 is greater than or equal to x. So the x is in between these two values. Again, we use a bracket because we have the equal sign at the bottom. That means that the point, whichever number you pick on, whichever point you pick on the graph, is going to be, it can be negative 6 or 34, so it is included. So the way we sketch the graph, you draw your number line. Negative 6 is on the negative side. Let's just say 0 is right here. This is not to scale. 34 is right here. And since this is a less than or equal to sign, or has a little equal sign at the bottom, and we use the brackets, not parentheses, we are going to use a closed circle. So you go to negative 6 and you mark negative 6 with a closed circle. You go to 34 and you mark 34 with a closed circle. And since you see that the x is pretty much in between these two values, you shade in between negative 6, 34, like that. So that is how your graph is supposed to look like. Again, x can equal negative 6. It's included in the endpoint. That's why it's a closed circle, and it also can equal 34. It's also included in the endpoint. That's why it's a closed circle. So this is how you are going to write it in this notation, like that. And this is how you are going to graph it. So that is how you basically solve this inequality. Now let's move on to number 2. Number 2. This is a regular inequality. It's not an absolute value inequality, and you notice that it doesn't have the little equal sign at the bottom. So we're going to go ahead and do this one. 6x minus 10 is greater than 26. So let's rewrite it. 6x x minus 10 is greater than 26. So again, we want to leave x by itself, just how we did here. So in order to do that, we add 10. And that's going to give us, let's just write right here. That's going to give us 6x is greater than 36. Because obviously this cancels out, negative and a positive cancel out this, positive plus positive you add obviously, so it's 36 is 6x, sorry about that, 6x is greater than 36. Divide by 6 because you want to leave x by itself. And now we have x is greater than 36 divided by 6 is 6. X is greater than 6. So this means that we see that we have a basically that greater sign. We don't have a equal sign at the bottom, so this sign indicates parentheses and an open circle because it's greater than. It's the endpoint is not necessarily included here, so open circle and parentheses. So the way we write that is parentheses 6 to and negative, and infinity right here, because this is indicating that x is greater than 6, so it can go all the way up to infinity, but it cannot be pretty much less than 6. So 6 parentheses 6 comma infinity. And one thing to note is that we never use brackets on infinity. We always use parentheses. So never one of these, always one of these in infinity. So in order to graph this, we draw our line. And we see that let's just plot 6 right here. We see that x is greater than 6. So again, we're going to use an open circle because it does not have the equal sign at the bottom. So open circle on 6. X is greater than 6. So what does that mean? We shade everything to the right of 6 because all of these values are greater than 6 and will satisfy the inequality. Like that. So 6 all the way to infinity because x is greater than 6. Open circle because the endpoint is not necessarily included here. So number 3, the absolute value of 9x plus 10 is greater than or equal to 91. So being an absolute value, again, we are going to do what we did with this previous absolute value. A negative 91, we rewrite this thing as negative 91. The same inequality sign, you put it right here, like that. And then take away the the absolute value, 9x plus 10 greater than or equal to positive 91. So now we just go ahead and solve by leaving x by itself. And again, we want to get rid of the 10, so we subtract 10 from all sides. This obviously is going to cancel out. 91 minus 10 is 81. Negative 91 minus 10 is negative 101. Your inequality sign, 9x. Negative 101 is greater than or equal to 9x, and so on and so forth. So again, you divide by 9 because you want to leave x by itself. Divide by 9. Divide by 9. So let's write it right here. Negative 101 divided by 9 x and 9. This is roughly equal to negative 11.2, I believe, but we're just going to leave it as a fraction for now. So negative 101, so pretty much, so x is less than negative 101 over 9, and x is actually greater than or equal to 9, positive 9. So x, sorry about that, so x is less than or equal to negative 101 over 9. So let's go ahead and draw what that will look like first before we do our notation. So again, we do our number line. And let's just put right here, negative 101 over 9. Let's put 9 right here. Like that. Positive 9. Let's just put a 0 right here. Not to scale again. So the inequality is telling us that x is pretty much less than or equal to negative 101 divided by 9. So, and since we have, again, the equal sign at the bottom of the crocodile mouth, we use, again, brackets and a closed circle. Remember that, because the endpoint can be included there. All right. So, closed circle on the negative 101 divided by 9. And we see that x is pretty much less than. Pretty much this is greater or equal to x. So x is less than or equal to this one, right? So that means that we have to shade to the left to make this inequality true. To the left. Because yeah, that's what this is telling us. That negative 101 divided by 9 is greater than or equal to x. So x is going to be pretty much less. X can be anything right here, but it could also be equal to negative 101 divided by 9. So now we hop on over to 9. Close circle, because again, we're dealing with that specific sign. And we see that x is greater than or equal to 9. So in order to make the inequality true, we have to find values that are greater than or equal to 9. So we shade everything to the right of 9 because those values are going to be greater than or equal to 9. Like that. And now we can go ahead and draw and write down our notation for this. So let's start off from here, making our way to here. So parentheses, remember we always use parentheses for infinity, we never use brackets. So negative infinity, because this pretty much indicates negative infinity, and it stops at negative 101 over 9. So comma, negative 101 over 9. And now we can use our brackets because we're dealing with a closed circle. Union. That is a symbol for union that pretty much unites these two. And we see that we have a 9 with a closed circle. So bracket 9, comma, infinity, because this goes all the way to positive infinity. And again, parentheses, because we never use brackets on infinity. So this is what your notation is supposed to look like. Negative infinity to negative 101 over 9 bracket union 9 bracket to in positive infinity. That's what this is pretty much telling you. This is going to be your notation. Sorry about that. That's going to be your notation. And one thing to note that just one thing to note, just an FYI, if this was a negative and you divide by a negative, this is going to completely change these signs. It's going to be the opposite. So this is just an FYI. I'm going to write it in red just so you don't get confused. So let's just say this is a negative and you divide by a negative. You do negative 9, you divide by a negative 9. These signs are going to turn this way, which will completely change, might change your graph and can change your notation, but that's just an FYI. You don't have to worry about it in this problem. That's just for your information. So now let's go on to the last one, number 4. Absolute value of x minus 4 over 4 is less than 4. So since this is an absolute value, we treat it like all the absolute values. So we rewrite it as negative 4. Again, the same inequality sign, x minus 4 over 4, like that. So now we just have to leave x by itself and from then on, it's simple. It's just like the rest. So in order to do that, we multiply by 4 because it's being divided by 4. This cancels out. So now we multiply by 4 every side, because what you do to one side, you do to the other side. 4 times negative 4 is negative 16. X minus 4. And 4 times 4 is positive 16. So now we can go ahead and basically add 4 because we want to leave x by itself, and a negative and a positive always cancel out. So that cancels out, obviously. Plus 4 plus 4. So negative 16 plus 4 is it's going to be negative 12. Negative 12 x, and 16 plus 4, positive 16 plus 4, that's 20. So that's how it's going to look like. So negative 12 x, negative 12 is less than x, and 20 is greater than x. So this is pretty much indicating that the x is in between these two numbers. So we can go ahead and write down our number line. And let's just put a 0 right here. It doesn't have to be perfect. Negative 12 and the 20. And again, since we are dealing with not one of those equal than or greater than or equal to signs, the ones with the equal sign at the bottom, we are basically dealing with something that says x is strictly greater than 12. I mean negative 12. So in this case, we use the open circle. So open circle on negative 12 and open circle on 20, like that. And since 20 is greater than x and x is greater than 12, this is pretty much telling us that, again, the values are in between negative 12 and the 20, the values that will satisfy this inequality. Open circle, because the endpoint is not necessarily found here. It's not really included. Like that. And we can write our notation down as parentheses 12 comma 20 parentheses. So that is how it's going to look like. That's your notation, and that is your graph. All right, that's how you do it.